In this video, we will show you how to get started with the Orange Pi 03W. The Orange Pi 03W is a single-board computer or SBC. It has a CPU, RAM, Wi-Fi, PMU or Power Management Unit. This is a USB Type-C port. It is used to provide power to the board. We connect 5V 3A supply to this jack. There is also a USB Type-C port that can be used to connect USB peripherals such as a keyboard, mouse, or pen drive. Don't connect this port with power supply. Now let's look at the main processor. This is the Allwinner A733 SoC. SoC stands for System on Chip. It contains the CPU, GPIO, NPU, memory controller, USB controller, display controller, camera controller, wireless interfaces, audio controllers, and several other peripherals. So, you can think of the SoC as the brain of the Orange Pi board. Every program that runs on the Orange Pi is executed by the processor inside this SoC. The Allwinner A733 has 8 CPU cores. It has 2 high-performance A76 cores and 6 efficiency A55 cores. These cores can operate at a maximum frequency of up to 2 GHz. The SoC also includes an E902 RISC-V real-time coprocessor. This coprocessor handles smaller or real-time tasks without always relying on the main CPU cores. For example, a simple task such as controlling an LED can be handled by it. Next to the SoC, we have the LPDDR5 RAM. LPDDR stands for Low Power Double Data Rate Memory. RAM, or Random Access Memory, is the temporary memory of the computer. This is the wireless module. The Wi-Fi and Bluetooth functionality is integrated into the wireless module on the board. And it also has external antenna. The board also provides a connector for an external antenna. On the other side we have micro SD card slot. The board also has a 40-pin expansion header. These 40 pins provide several interfaces, including UART, SPI, I2C, PWM and General Purpose Input, Output, or GPIO. The board also provides 2 camera interfaces, Cam1 and Cam2, which can be used to connect compatible camera modules. We also have PCIe port, UFS or Universal Flash Storage, eMMC storage, and this is the LCD port. We can connect MIPI LCD with this port. The board also comes with a heatsink and a fan for cooling the board, thermal pads, screwdriver, and screws to connect this thermal shield with the board. Now we add this thermal pads on these chips. And then we connect this heatsink to the board. Now our hardware is ready. Before we can use the Orange Pi, we need to install an operating system. First, we search for the Orange Pi 03W in a web browser. Next we go to the official Orange Pi website and locate the software or download section for the board. We will download Ubuntu in the Orange Pi board. And we need to download desktop, not the server. For desktop we go to this. It's the latest one, and then we download it. Click on Download Anyway. Click on Save. Now to burn the image on the SD card we need software. Here we are using Rufus. We download the Rufus software from the official website. Download Rufus for Windows from here. Now we install the software. After installation, open Rufus. This is Rufus software. Now we set the SD card. Next we select disk or ISO image. Click on Select. Double-click on it. And this is the Orange Pi image which I have downloaded. Now click on this. We click on Start. Now we eject SD card. After uploading the Linux into this SD card, we insert the card here. This SD card does not come with the board. This is the 5V 3A power supply. It also doesn't come with the board. And fan controller has 2 pins which needs to be connected like this. Now let's connect out power adapter here. And connect the docking station over here. This is the Bluetooth receiver for out Bluetooth mouse and keyboard. We need to connect it here. This docking station is connected to USB 3.0 host of the Orange Pi board. Here is the Bluetooth keyboard and mouse. And this is the HDMI monitor. Now connect mini HDMI cable over the HDMI port of the Orange Pi board. Now we turn on the power supply of the Orange Pi board. When Linux boots for the first time, you will see the Linux desktop on the monitor. We can use the desktop environment just like we would use a normal computer. The first thing we do after the system boots is we connect it to a network. We click on the network icon and connect to our Wi-Fi network. Then we enter the Wi-Fi password. When the network icon shows that the connection is active, the board is connected to the internet. Now, we can use applications such as a web browser. Open the application menu and go to the terminal. This is the terminal window. Now we need to update the system because the Linux image we installed may not contain the latest versions of all available packages. To update the package information, we use sudo apt update command and then press enter. The system will ask for the password. Here password is Orange Pi. Enter the password. The command checks the available software repositories and determines whether newer packages are available. If updates are available, we can install them using sudo apt upgrade. The system may ask whether you want to continue. Type Y and press enter. Linux will then download and install the available updates. The update has been completed. Now let's check what development tools are already available on the system. We will first check the installed GCC version by running gcc version command. This displays the installed GCC compiler version. In our system, the GCC version is 9.4.0. Next, we can check the Python installation. It confirms whether Python is installed and shows its version. Let's check the system resources using the htop command. As you can see, Orange Pi 03W has 8 CPU cores. At the time of testing, the system showed a total of approximately 5.72 GB of RAM, with around 1 GB being used. We can also see the number of active tasks running in the system. The CPU utilization of the individual cores changes depending on what the system is doing. Some cores may be heavily loaded while others remain lightly loaded. This is because Linux distributes different tasks among the available CPU cores. Now let's test the multimedia capability of the Orange Pi. We will open a video in browser. Start a video and observe the system resource usage. Here we can see all the cores are being used. Observe the core usage. While the video is playing, the CPU activity changes because the system is processing the video workload. The number of running tasks also changes. Now let's play a 4K video and observe resources usage. We can see all the cores are working at full efficiency. The number of tasks running also increased. Now let's monitor the CPU temperature of the Orange Pi. We have already prepared a temperature monitoring script. The script continuously reads the available thermal sensors and displays their temperature values. Let's run the script. We can now see the temperatures reported by the system. During the workload, the CPU temperature is around 75 degrees Celsius, while the GPU temperature is around 68 degrees Celsius in our test. Now let's close the browser and stop the 4K video. As the workload decreases, we can see that the processor usage also decreases. The temperatures begin to drop. The fan connected to the Orange Pi is also running. The number of active tasks decreases as background applications are closed. This demonstrates an important point. System temperature depends heavily on the workload running on the board. When the processor is under a heavier workload, its power consumption and temperature generally increase. When the workload decreases, the temperature gradually falls. Now let's test one of the GPIO pins. We are going to use PB0. PB0 corresponds to physical pin 11 on the Orange Pi 03W's 40-pin header. We will configure PB0 as an output pin and toggle its voltage level every 500 milliseconds. For this demonstration, we will use the wiring OP library provided for Orange Pi boards. We already have two terminal windows open. First, let's check whether the wiring OP library is available on the Orange Pi. We can use the command GPIO read all. This command displays the GPIO information for the board. The output shows the physical pin numbers, GPIO names, current pin modes. This allows us to see the state of the GPIO pins. Now let's locate PB0, which we are going to toggle. And currently it is in out mode. Try to toggle this pin. For that we need to continuously call read all function. For this, we have created a GPIO monitoring script. We can run it using /GPIO_monitor.sh. The script repeatedly runs the GPIO status command and refreshes the screen every 100 milliseconds. Let's see how we can toggle the GPIO pin using the terminal. Here, PB0 is configured as an output. The wiring OP number for this pin is 5. Now we can write a high value to the pin using GPIO write 51. The value 1 sets the GPIO to high. For this board, that corresponds to approximately 3.3 volts. Now let's set the pin low using GPIO write 50. The pin is now set to low. We can also change the pin to input mode using GPIO mode 5 in. This changes the GPIO configuration from output to input. We can also change it back to out mode using GPIO mode 5 out and again toggle it. To come out of the script we will press Ctrl+C. We can open the script using the Nano text editor. By using nano GPIO_monitor.sh, we can see what's inside the script. The GPIO information is refreshed every 100 milliseconds. And we can come out of script using Ctrl+X. Now let's control the same GPIO using a C program. We have already created a C source file for the GPIO toggle example. Open the code using nano002_GPIO_toggle.c. In this example, we use the wiring OP library to control PB0, which is physical pin 11 and wiring OP pin number 5. The program first initializes wiring OP and configures the pin as an output. It then continuously sets the pin high and low with a 500 millisecond delay between each state. Now we compile the program. We run the program using sudo command. We enter the password when prompted. GPIO is toggling every 500 milliseconds. The pin repeatedly changes between high and low. To compile the C program, we will use GCC with the wiring Pi library. After compilation, run the generated program using the sudo command. To stop the program execution, press Ctrl+C. Thanks for watching.